So this is a numerical of gas absorption. We can you can refer to the question. I haven't received any kind of question here. So it is been given that the volume is 0.25, T2 is given as 26 degrees Celsius. I have converted this into Kelvin, and N2 I don't know the number of moles. P2 is also given as 1.07 into 10 power 5 Newton per meter square. Now we know that at HTP N1 is equal to 1 kilomole, V1 is equal to 22.41, T1 is 273, and P1 is 101.33 into 10 power 5. Now this is equation at HTP is equal to P1 V1 equal to N1 RT1, and at normal temperature at given temperature, we can write this as this P2 V2 equal to N2 R by T2. Now if I divide 1 by 2, I will be getting P1 V1 this relation. Now I know everything except N2, right? Everything I know because T1 represent the HTP conditions and T suffix 2 represent the our own conditions, right? So by comparing this I'll be calculating this N2, right? I know everything, so I'll be getting the N2 as 0.01075. Now gs, if you define gs is a moles, okay? So gs is also a N2, okay? So whatever the gs, so your gs will be a 0.01075. Now similarly in the drying operation here also, if it is given y1 is equal to 0.02, we have to convert this into y1 upon 1 minus y, okay? Just like wet to dry, so here also we'll be getting y1 as 0.0204. now what y1 exactly it is, let me explain with the diagram. uh, the diagram here is, this is a gas absorption column, okay, let me this is a gas absorption column. Here gas will be entering, this is gs with concentration of y1. Now and it will be leaving with the concentration of y2. Now this concentration they are given as 0.02, so we have to convert this 0.02 into y1 upon 1 minus y terms. So 0.02 upon 1 minus 0.02, if you write this, then you will get as y1 as 0.0204. Similarly we are given the, and this flow rate actually we have to write in the terms of 1 minus y. This are the you have to do like this, you have to mug up. There is no other way. I don't know exactly explanation why you have to do in this way, but yes, whatever the gs you have got here 0.01075, you cannot use directly in the numerical, so you have to convert this gs into this form, 1 minus 0.0202. So when you do like this, you will get this gs as 0.010535. okay? Now it is also given in the question that we need to reduce the concentration, this concentration as said. If you are entering this y1, this concentration has to be reduced to 95%. So if 95% is reduced, then the leftover will be the 5%, right? If the 95% is reduced, then the leftover will be the 5%. Okay, so the concentration y2 is equal to 0.05 into y1, right? 5% is 0.05. So you will get as y2 as 1.02 into 10 power minus 3. Okay, now we got the detail as y1. We know y1 is the amount of concentration that is inletted, and y2 is the amount of concentration which is removed. Now it is also given in the question that x2 is also given. I have forgotten to write here. x2 is also given as something 0.05. So if you see x2 upon 1 minus x2, you have to come this also 0.504. okay, so h2 is also given. Now what we have to find is x1. okay, so we have to find this x1. This we can find easily through the graph. okay, so in order to draw a graph, first of all you need to have a equilibrium data. Now if you see the statement I have written that in question no equilibrium data was given, hence we need to generate equilibrium data, and in order to generate equilibrium data we have to derive a relationship between y and x star. So y star is equal to PA by P2 into x star. Now here y you cannot just write directly as y. You have to write y as 1. We all know that y is equal to y star upon 1 minus y. In here itself I have said that y into 1 minus y. So here this y is not capital Y. Actually it is a small y. Hence I represent the star letter. So y equal to y star upon 1 minus y star. So if we solve this, y star will be get as y upon 1 plus y. Similarly, x star is equal to 1 plus x. So the relation will be like this: y star equal to 1 upon 1 plus y star equal to p by pt into x upon x star. And it is given that p is given as 13330 and pt is also given as 10700. So if we solve this equation, now what we will do is we will assume the different value of y. Now how to assume value means, see, if you see the inlet concentration which was 0.0204, and if we see this concentration 1 into 10 power minus 3, so if we take the value between 0 to 0.024, they both will lie. So we can generate the value. Now see, if you see the 0, 0.004, 0.008, 0.012, I have taken different value of 0.04. So particularly I have substituted the value of y, I have got the value of x star, so I got this generation. What I do is I'll plot a graph. I'll plot a graph like this. Y is already, I have x with the data. I'll plot a graph. I'll get this curve. Okay, now this is the operating line. If you see this is actually a tangent to this curve. Okay, so I am writing this operating line. Now it is given in the question that the L actual is 1.5 times of L minimum. So in order to calculate this L minimum, similarly in the distillation type, what we'll be doing is, see, our concentration was 0.0 L1. If you see L2, this is 0.0204. If you take this 0.0204, this 0.0204, and if you extend this line up to this operating line, and if you get this drop here, this x1 whatever will be, this will be x minimum, because whenever this line curve touches this tangent line, it will be x minimum. Okay, so whatever the x minimum you are getting, okay, we'll get x minimum as 0.175. Now I will substitute here this. I know that this is a relation minimum gs ls equal to x gs into y1 minus y2 minus x1 minus x2. I will substitute x1 as a 0.175. So if I substitute x1 as 0.175, whatever the L will get, I will get, that will be my L minimum. Now, but it is given that L actually is equal to 1.5 times of L minimum. So I'll get the L as 1.75. Now what I'll do is I'll use the same equation. I'll substitute L as 1.785. I'll calculate the x1. Okay. So when I calculate the x1, I'll get the x1 as 0.1190. I'll substitute, all the values will remain same as it is. GS, y1, y2, y3, all those except x1. So I'll get x1 as 0.1190. So this is the final answer. So now our aim was to calculate just x1. I'll summarize once again. We know y1, we know y2, we know x2. All in all, we need to find this x1. So what we have done is we have plotted a graph between y and x. From y and x, there is a phenomena of x minimum. Whenever there is a minimum phenomena of minimum, we will draw a tangent to the curve and we'll extend this point. Whatever this point will be, this will be the x minimum. Okay, thank you. If you have any doubts, you can feel free to contact me.